female I'm going to put back in the anesthesia compound, and we're actually going to euthanize her so that we can collect blood. So I'm going to show you how we collect blood from these minnows. Depending on how much blood we need, we may be able to non-lethally collect blood using a syringe, but if we need a larger volume of blood, we do have to euthanize them. So fish do not have as complicated a circulatory system as we do. They have a heart that has 2 chambers, and they don't have veins and arteries that are as branched as we do. So actually what happens is blood collects and pulls back in this tail region, and there's not enough pressure in that circulatory system for the blood to reach back, to get back to the heart without muscular movement. So when the tail is moving from side to side, that's actually is what pushes the blood back to a fish's heart. So when we anesthetize them and put them out, that blood pools in this tail region. So what we're going to do is we're going to just sever that tail, and we can collect that pooled blood for analysis. I'm going to collect blood in a capillary tube. So you can see I can just draw that blood right out of that region where that blood pools in the tail of the fish. Collect this blood and do some sample. On the other side of the hallway in one of our labs, we have our organisms that we raised, and we do dissection mainly. On this side of the hallway, we have another one of our labs where we have most of our analytical equipment. And so we will bring our tissue samples over here and process them and run them through certain pieces of equipment depending on the question that we're asking and depending on the type of data that we need to collect to test our hypotheses. So we would process this blood sample in a different way depending on the question that we were asking. And eventually we would get to the point where we would be weighing out micro samples. And so we weigh out micrograms of sample, which is why this can actually be 3 pieces of data with this smaller volume. We would weigh them out, and we would actually process them in one of our pieces of equipment. And one of the pieces of equipment that we use a lot is this collection here. And all of this together is called an IRMS, and that stands for Isotope Ratio Mass Spectrometry. So we look at isotopes of carbon and nitrogen as well as just total carbon and nitrogen. And what is an isotope? Well, that's something I hope you guys can tell me when I come out to your classroom. So we would process this and run it through and get a result that looked like a gas chromatogram. Process the sample and run it through this series of equipment. We would get something like this, which is called a gas chromatogram. And basically, all of the atoms that we are interested in get combusted into a gaseous state and run through this system, and these peaks show us how much of that particular atom or element is in the sample we are testing. So I'm really excited to come out to Mayfield High School and be with you guys this semester, and I'm thinking about some experiments that we could do. One of the ideas that I had is we could take hair samples and run it through this particular series of equipment and see if we all are eating the same types of carbon and nitrogen atoms. It would be really interesting to see if some of us separate out into groups, which shows us that we are eating different sources of carbon and nitrogen than others, or if we all sort of fall in the same area. So I think that would be something that would be really exciting, is to take hair samples and figure out what your diet is.